Hello, my name is Carolyn Chapel, and this video I'm going to talk about counting techniques when it comes to probability. Probability is finding the chance of something happening, and when we started discussing probability, we found that to calculate the probability, we needed to know the number of ways something happened over the total number of ways in that sample space. And the examples we had were usually small. So like rolling a die, there were 6 possible outcomes, and what's probability of getting a 4? Well, there's only 1 4. Things get a little bit more complicated when finding the number of ways something can happen is a little bit more complicated. So we're going to learn some techniques that can help us figure that out. And the first one is something we call the multiplication rule of counting. Multiplication rule of counting. And this does have a couple of different names in different textbooks, but basically it's our multiplication rule when we're talking about counting things. And what it says that if a task, so we have some sort of event that we're going to be doing, and it will consist of a sequence of choices. In which these things there are key selections for the first choice, let's say Q selections for the second, and we'll go with R selections for the third, and we can continue this on forever or for a number of times. Then it turns out then the number of ways we can perform this task is this task is your P times your Q times your R times whatever values you have until we get done. To kind of see this in this multiplication rule happening, we can think of a tree. So let's just say take a task that we're going to get dressed. Okay, and let's just say you own 4 shirts and 3 pairs of pants and 5 pairs of shoes. Okay, and we're going to create an outfit. So we're going to be putting these things on. We're going to get 1 shirt, 1 pair of pants, and a pair of shoes. And we want to know how many outfits we'd have in the general sense of the word. So think about a tree to help us out a little bit. And here you are. We're going to create this tree and we're going to get dressed. So now we have 4 shirts. So that means I choose any one of those 4 shirts. Okay. And from each of those shirts, I have 3 pairs of pants. So each of these would have 3 different branches from them. And right now you can see that we do have 4 groups of 3, which is 12 different outfit so far, as long as we don't put shoes on. So the 4 times that 3. Now imagine further that we're going to put those shoes on. My tree's going to get very, very messy here. But from each of these, we'd have our 5 shoes. And I'm just going to draw a couple of them here so you can kind of see the idea. So we would have that 4 times our 3 times our 5, or there would be 60 different outfits. And by drawing the tree, if I had drawn the complete tree, you would have seen all 60 different paths that we had. Let's do another example where you can kind of see this. Let's create a password. Create a password. And just for making things a little simpler, of, let's say, 7 characters. And we're going to only use the letters, only using the letters of the alphabet. And we're also going to say that we, with no repetition, first of all. In other words, we're not going to allow our letters to be repeated. So if I use the letter A, I can't use that letter again. Okay, so we have to, our task is to create this password. And now you could draw this tree. Here you'd be standing and you'd have to choose that first character. Well, the alphabet, first thing you have to remember is that the alphabet has 26 letters. And we're just going to not worry about uppercase and lowercase. If you did and it was case sensitive, that just doubled it to 52. So you could do this problem again with the 52. But we have our 7 tasks. So I like to put those tasks kind of spaces for them. So 1, 2, 3, 4, 5, 6, and 7. And we're going to try to say, okay, for the first task, I have 26 options open to me. So if I were drawing a tree, I'd have 26 branches, 1 for each letter of the alphabet. From there, my second choice of that second letter, I only have 25 options because I'm not allowed to repeat myself. And now I can't use any of the first 2, so I now only have 24 options, and 23, 22, 21, and 20. And then, excuse me, what we do then is, if you can imagine your tree, we were going to multiply all those pieces together. Now, I'm not actually going to write the number down for this, but you will see that it is quite large. And if I allowed for uppercase and lowercase, we get an even larger number. If I allowed for all the numbers and all the symbols, this can get incredibly large. Okay. If we allowed for repetition, that's an R. If we allowed for repetition, then our number just becomes this. We'd have 26 choices at each spot. So again, it becomes a little larger than it was before. So we'd have 7 26s, or just that 26 to the 7th power, whatever that value happens to be. And of course, that we are looking at, I'm confident that you guys can drag out a calculator and evaluate those pieces. Okay, so there are lots of examples that you can go through to do something like that. But again, this principle of multiplying the number of ways each task can be happened, can even get more complicated in the future. So, but I'm going to, before I get to that point, we need to talk a little bit about something called a factorial. And it is denoted by some sort of number, and I'm just going to use a letter N to represent a number, with an exclamation behind it. And N is going to be a positive integer. So like 1, 2, 3, 4, 5, and so on. This is defined to be N times N minus 1 times N minus 2, all the way down until we get to 3 times 2 times 1. So for example, with values, if I had 7 factorial, is how we pronounce it, it is your 7 times your 6 times 5 times 4 times 3 times 2 times 1. And if I were to drag out my calculator, this turns out to be 5040. Doing all that multiplication is quite tedious. And because this factorial shows up often enough, a lot of calculators have put this in on their calculator. Sometimes you will see it right as this N with a factorial key. My calculator, which happens to be here, the TI-30X, these are going to be hidden under this PRB button. So if I hit this PRB button, see if I can get this to show up without the glare. There we go. We'll see this NPR, this NCR, and I'm getting to those shortly. But we also see this little exclamation point. So if I wanted to do 7 factorial, I would hit my 7 key first. Then I'd go to my PRB. I'd arrow over to get that exclamation point, hit my enter, and you can see the exclamation point show up right there. And then I can simply hit the equal button, and there's that 5040 that we talk about. Notice that these things will get large quickly because multiplying 14 factorial, we get like a times 10 to the 10th, so very large. We also needed to make things work for us. Oops, definition, I did not spell that right. Is we need to have 0 factorial. For our formulas later to happen, we actually define 0 factorial to be 1. And that is entered into most calculators, that they do come out like that. You'll see the 7 factorial or the 0 factorial giving you the answer of 1. And the reason this factorial is nice is if you remember our password, we saw this 26, 25, 24, 23, 22, 21, 20 idea showing up, which looks like part of a factorial. And it is part of a factorial, and this factorial shows up even in complicated problems like that as well. And the thing that they're involved in is something called a permutation. And a permutation is a way of finding how many things, ways something can happen. And I like to think of it as an ordered. And this is a big key thing, ordered arrangement. In which our things are chosen from n distinct objects. Okay. And also when we're talking about a permutation is repetition is not allowed. Not allowed. So for example, this problem we just did, we had those 26 letters. Our example is we were choosing 7 things from the 26. So that kind of helps us out a little bit. The notation we use, at least in this textbook that I'm kind of following, is an N PR. Other books will do it as an P comes first. I've seen it in other forms as well. The formula for it is your n factorial divided by that n minus r factorial. So for our example, again, this would be 26. We're choosing them from 26 things. We are picking 7 of them. I like to use the word pick because we're going to put them in an order. So we would have 26 factorial over 26 minus 7 factorial. And 26 minus 7 is 19 factorial. And I want to just kind of talk through this. 26 factorial is 26, 25, 24, and so on and so forth. And 19 factorial is 19 times 18 times 17, all the way down until 3 times 2 times 1. Eventually, we're going to get these guys. Notice these would all cancel. We'd have this piece here, which is exactly what we had before. Okay, and we can do this on our calculators. You may have remembered that little PBR button. You saw that NPR, that was first thing. So what we're doing to use that on our calculators is we're going to type in the 26 first. Then I'm going to go into my PBR button. I'm going to get this NPR that I want. And I'm going to type in my 7. And we're going to hit the equal button. And we get that large number. So we have that 331531200, which is exactly what you would have gotten had you multiplied all those pieces together. Okay, so a permutation is something when we order our pieces. So example, like in here, if we change these 2 letters around, our password would be different. There are situations where the order is not important. So that is called a combination. And that is, I would just say, a collection. And again, without regards to order. Of n distinct objects. And again, without replacement. So not allowing us to repeat these pieces. The formula for this, first of all, our notation, we use a C for a combination. P is for a permutation. And the formula for this is going to be our n factorial over r factorial n minus r factorial. You'll notice we have most of the pieces from that permutation in here, but we're going to divide it by another piece. What that's going to do is it's going to take one combination or one ordering and allow us to reorder those same numbers and not count them twice or 3 times or however many times it is. Okay, so some examples that we might have of a combination. Let's say you have a number of books. Let's say we have 18 books, different books. Okay, and let's say we want to choose 3 of them to take on vacation. Okay, when we're trying to decide which ones to take with us, the order in which we pick them really doesn't matter. So this would be a situation where we'd have a combination. So that 18 choose our 3. If we were worried about the order in which we read them, then it would become a permutation. So we have to be a little bit careful on how we do things. Okay, I'm going to do another example. And then I probably will stop this video and then do another video with more examples and what happens if we don't have distinct objects. So let's say we have a group of people. And let's say this group has 8 men and 6 women. And we are going to create a committee of 3 people. Okay, and we might want to know how many ways can this be done? How many ways can we choose these different groups? How many ways or how many different, let's go different, committees are there? Okay, so in this situation, we're kind of lumping all of our people together. So we do have 8 men, 6 women, so a total of 14 people, but we want to know how many different committees. Now, the order in which you're on this committee really doesn't matter if you were chosen first, second, or third. You're either on it or you're not on it. So the answer to this one would be that 14 choose 3. Different from if we wanted to, how many ways can we choose a president, vice president, and secretary, or note keeper, or whatever you want to call them. Okay, here the order or the labeling makes a difference. Who the president is, who the vice president is, and who the secretary is makes a difference, because if I switch roles, we might have a completely different look. So this would be a situation where it would be a permutation. Okay, so hopefully here you can see the difference between a combination and a permutation. I'm going to stop this video here and I will pick up another video where I will do some more examples with the same group. Also talk about how we would turn these into probabilities, and then talk also about what happens if the items are not distinct.